Okay, moving on. A random sample of distances travelled to work for 120 commuters from a train station in Devon is recorded. The distances travelled to the nearest mile are summarised below. For this distribution, estimate the median. Okay, so are there any clues of what we need to do in the question? The question was actually quite straightforward. Maybe here to the nearest mile, so I know these values have been rounded. Quickly looking at these intervals, 0 to 9, 10 to 19, 20 to 29, this should be a continuous distribution, and there's going to be a gap at the moment in between 9 and 10. So I need to add in some class boundaries, and that's going to take us to 9.5, 9.5, 19.5, 19.5, all the way down. Okay, and another thing that stands out to me immediately is that I'm trying to locate the median. I'm going to need cumulative frequencies on here. So just next to each of these, I'll add in some cumulative frequencies. Okay, I'm quite confident I've got those correct since I ended up with 120, which is a value that the question gave me. So let's track down the position of the median. So Q2 is going to equal n plus 1 over 2, which in this case is 121 over 2, which is the 60.5 value. Which interval is that going to be in? Making our way through the cumulative frequencies. It's not going to be in the first interval, neither the second. It's going to be in the third, because the third goes past 60.5, starts at 29th, goes all the way up to the 72nd. So the 60.5 will be in there. Let's set up diagram. So we know it's in the third group because the third group would have started on the 29th value and gone all the way up to the 72nd value. The class boundaries for that third group are 19.5 all the way up to 29.5, and we're trying to track down our median, which we know is going to be the 60.5 value. Evidently, is going to be closer to this end if it's the 60.5. And from this diagram, we should be able to set up our calculation to represent the linear interpolation. Okay, so this turns into our fraction. And from here, it's really rearranging until we get the value we were looking for. And finally, in a couple of steps, we can get and now's the time to pick up your calculator to get an answer of 26.8256, 4 decimal places. The median is 26.8256. Okay, so the midpoint of each class was represented by X and its corresponding frequency by F. The midpoint of the lowest class was taken to be 4.75 and led to these summary statistics. The sum of Fx is given and the sum of Fx squared is also given. So estimate the mean and standard deviation of this distribution. So some of the legwork's been done for us already. Okay, so we're off to find the mean. So X bar, we know the formula that we know. Sum of Fx over the sum of F is going to equal the value we've been given in question all over the total frequency, which is 120, and that leads to our answer. If we quickly put this into the calculator, 29.6041. Okay, so we also want to be able to find the standard deviation, the sample standard deviation we'll assume, and we're going to need to calculate S of XX. So the S of XX we know is the sum of Fx squared minus n X bar squared. All right, nicely, we have all of these values already. So let's go ahead and slot them in. Sum of Fx squared minus n is the same as the sum of F. So 120 times X bar squared. I'm actually going to use the fraction for F bar squared to maintain some accuracy. And this just needs to be put into the calculator, which is 32,874.3229. Okay, so to 4 decimal places, my S of XX. Okay, and a little more to go so that we can find the standard deviation. So standard deviation is going to be the square root of S of XX, all divided by n minus 1. So that's going to give me the sample standard deviation. Go ahead and plug those values in. So just being smart to use the answer button once again to try and maintain accuracy leads to an answer of 16.6209 to 4 decimal places. Maybe more than you need, but definitely making sure we get our mark for that. Okay, so in part C, we're asked to explain why the median is less than the mean for these datas. Well, our median, if we come back up here, was 26.8, whereas our mean was 29.6. Firstly, what type of skew is this? This is positive skew. Since the mean was larger than the median, we have positive skew. And can we see any reason why there might be positive skew? Well, when we come back to the original data, we can see that there's only a few values at this top end, and a lot of the data is down here with these lower values. So you would expect for the median to be somewhere in this region, whereas the mean is getting pulled in this direction as we have positive skew. Okay, so a couple of different ways to explain what's happened there. Okay, so 2 reasons here. Positive skew, so the mean will be the larger of the 2. We have positive skew, which we can see from the values in the original diagram, which means the mean will be the larger of the 2. And secondly, which is a little bit more informal, there are a few large values pulling up the mean. Same as the definition of skew, but a little less formal. Okay, so for a second random sample of 120 commuters travelling to work from a train station in Greater London, the mean distance travelled to work is 15.6 miles, with a standard deviation 21.2 miles. Compare the measures of location and spread for the distance travelled to work for the 2 samples, giving possible reasons for any differences. Okay, so firstly, I'm just going to rewrite each of these summary statistics close to each other. Okay, so really just putting these into a table for easy comparison. First, we'll start off with the means. Devon has a larger mean than Greater London. The mean distance to travel to work in Devon is 26.9, where in London it's 15.6. What might be a reason for this? Well, with Devon being more rural than London, people will need to travel further to get to industrial places or to get to business centres or to get to their places of work, whereas Greater London is a lot more compact and people's workplaces are just likely to be closer to them. And looking at the standard deviations, we can see that London actually has a greater standard deviation than Devon. And a reason for this may just be that the commuters at the Greater London train station just have a higher variability of distances that they'll be travelling. So they're not all travelling to similar places or places that are a similar distance. Some are going very short journeys, some are going quite further journeys. And there you have it, a comment on the mean and an interpretation on the mean, and a comment on the standard deviation and an interpretation of that standard deviation. And that should be worth all your marks.